This is my server, by the way, running in Chrome. Isn't that awesome?
I do like that.
Right. So, here's the lab. Okay. So, so it's, as we, with the thing, when we had this session with James, um, so here's basically the problem. You have a database, it has some tables. There's one table for the like matches that were played in Germany. There's one table for the teams. And so our goal is to find the name of each team, the total number of goals that they scored in 2011, the total number of wins, a histogram, and the win percentage on days where it was raining in 2011. Um, so a good thing is so you guys remember, we saw the tables, right? So we kind of know what's in there. Um, uh, so
Yeah, and I think you got more complicated in pulling your data out of there, right?
I'll show you what I did differently down the line. I did the second SQL query, and I think James did it through Pandas. And I thought about doing it through Pandas, but then I was just like, I thought it was just easier to just do one. So this is the one. So I just wrote the one, and this is to get. I forget what this is doing. Let's. I'll get to it. Let me see. Let me walk down. Okay. So this over here is kind of what the matches table looks like. You have a match ID, there's division, season, the date, who the home team was, who the away team was, what the home goals were, what the away goals were, and who won. Right, and then this is the precipitation is what I added afterwards. But the original table doesn't have that. Right. So the big challenge here was, right. First, let's get the weather. Okay. So we have this is the match table, and it doesn't tell us what the weather is. So the first class that I wrote was to get the weather, right? So this is up here, we're importing our libraries, we connect to the database. The first query we do is select all from matches where season is 2011, because the matches table has data going back, I think, a lot of years. So we just wanted 2011. So we pulled all the matches that were played in 2011. And that's what we get. We turn that into a data frame. This is the API keys function. It's the same as what we saw. It's stored in my secret folder, and then you give it the path, and it gets the key for you. So this is our first class, right? So the way that I went about this is that the first thing I wanted to do was I wanted to get the weather for each match up front before I even started parsing it out by table, because my thought was that we're going to have to analyze all of this data for all these matches. So we're going to need a rain value for each match. So we may as well just get the rain or clear for all of them. And I think that's how also they did it in the solution, and that's maybe also how James did it. The difference is that the solution in James, they did the thing where they pulled all the unique dates, and then just made API calls for each unique date, and then they filled it out. I was kind of lazy, and I just kind of looped through each date. So I made like redundant calls, and I thought about doing the dictionary, and I'll sort of say like how they did it, but I just got lazy and I didn't do that. So what I do is I get the weather getter class up here. Okay, on initialization you pass it the API key and one date, right? You give it the base URL, and then you do dot format. Just put the API key in there. That's how I'd set up my base URL, and then do the date query. And this is, I think James did this differently. I was a little distracted when we had the thing with James. But I don't know how did he do his dates? What did he do to his dates?
He pulled the dates out of, and that's kind of how I did it too. I have this part done, where I just pulled all the unique dates out of the table,
right?
And he built it based on that. So let me go look really quick.
Did he format it in this way, or I feel like did he turn it into like whatever the serial Unix timestamp or something?
Let me see. He had a check date, which was another function that was pulling out of the table of the date.
Yeah. No, but like, how did he, when he sent the date in the API call? how did he actually format the date?
Oh, yeah. He added, well, like I said, he pulled the date and then he added the time suffix on the end.
Okay, so the same as this, like there was
Yeah.
T12. Okay, yeah. And it's in the documentation will tell you how to like format this. And I remember you guys were like looking at the documentation and
I know. You know what I got confused about? I was trying to format in the dashes, but I didn't realize that that the dates themselves, when you just listed them, had the dashes. So that was one thing I was running into.
Yeah.
So you just let it pull.
Yeah. And also, like it wants the timestamp with the T, like the T for like I wasn't putting the T, and I didn't notice the T, but the T is apparently like it's part of it. And I think that's like a standard.
You need it.
Yeah.
And you need that question mark in there too, I think. Did you use?
Yeah.
Okay. That was something else.
Right
I was like, what?
Yeah. Yep. They're very you have to be like kind of really specific about whatever it is that they want. So time machine, go down, required, right? So it says time. Either be a Unix time, this is some kind of like serial time calculation thing, or a string formatted as follows. So that's 4-digit year dash 2-digit month dash 2-digit day, then the T, and then 2 hour, 2 minute, 2 seconds, and the time zone is optional. So yeah, just be mindful of the spaces and the dashes in the overall format. It really wants it to be just like that. And like when I work with APIs, I always find it really useful to look at like the example requests, and that really gives you can sort of reverse engineer that, and it gives you an idea. So that's your
I found that too.
Yeah, there, and then you can exclude, and then after the question mark and the exclude, you can tell it what not to pull because otherwise it pulls in a bunch of stuff you don't need. I in particular excluded like I think the minute and the hour and all that stuff that you don't want. And the solution does that as well. So that's how that, yes.
Yeah. I ended up excluding currently, minutely, hourly, alerts, and flags. I excluded anything except for daily.
Yeah. I just did minutely and hourly because those were the most, that was the largest volume of information. But yeah, you can exclude whatever you don't need. I was just kind of winging it. So then we do so now we get the response. We have our query set up in the base URL. So we're going to do request.get date query, and we're going to pull the JSON for that response. And that brings us back the JSON dictionary in response. And then I put it in my function to sleep for 0.2 seconds. Before it gets, because this function works on one date at a time. So each time it gets a date, it'll just wait 2 seconds here, and then if it's in a loop, then it'll go to the next date and then wait 0.2 here as well. Then to get the probability of precipitation, you take the response and you slice that dictionary by first you get to daily, and then to data, and then 0, right? And you remember from his lecture why that is the case, because that's the structure. The one difference is that the solution in him, they went for icon, and like I mentioned in lesson, when I tried to go for icon, there was some values where icon did not have a value. I actually tried a bunch of different like slices to see which one to get. Like if you go down here, so that's the data slice will have it's a list with a dictionary. And that's all the stuff, the data points that you can pull. And icon is like right here somewhere, right? Isn't it?
I saw it in there, and that's what I was going to choose.
Yeah. Well,
but I remember he said he said when he did it, when he was off just kind of doing it by himself, he did it the same way you did it. Yeah. And I was going to still do the icon.
Yeah, well,
I just figure like that's what they put as like if it's gonna rain, that's what they get.
Yeah, so obviously you would think so, right? And that's what I thought as well, because I saw icon in snow, and then when you read the thing for icon down here, right, it'll tell you data point object. This is the one that walks you through what they all are. So that's icon. It's a machine readable text summary suitable for selecting an icon for display. if defined this property. And when they say if defined, that's kind of what freaks me out, because it implies that it may or may not be defined, right? The problem is that, like, it seems that most of them, a lot of them have the if defined language. Um, and yeah, because I did in fact run into values where, like, there were dates for which there was no icon. I don't know why, but there just wasn't. So then I just started going through all the other data points to see, well, I'm trying to figure out whether it rained on that day or not, and which one's the most pertinent. So you go down to precip, because precipitation is what we're trying to get for. So you look at all the different precipitation data points to see which one is useful. So at precipitated accumulation, right? Amount of snowfall, accumulation expected in inches. If no snowfall, the property will not be defined. Now they're only using snowfall, so I don't know if they mean rain or not. So I'm like, whatever. And then it's the intensity in inches of liquid water of precipitation. This is conditional on probability, assuming any precipitation occurs at all, right? So again, it's conditional on another thing, which makes me think that there might not be a value here. So I went down to precipitation probability. It says the probability of precipitation occurring between 0 and 1 inclusive. And to me, this felt like the most robust one, because it's also kind of Boolean. So, like, either there was probability or there wasn't. So that'll spare me from having to write, like, a if intensity is greater than 0 kind of condition myself. And also, it seems that that's built on this anyways. So, I mean, I wasn't 100% sure on whether probability meant, like, what they had predicted the chance of rain was be, and not whether it actually rained that day. But I think that this was, like, telling you in the time machine, it tells you whether it did or did not rain, because I just sort of manually compared some of the values. And yeah, when it was raining, the precipitation probability was 1. When it wasn't raining, it was 0. So I kind of just used that. And this was always, and there's no conditional language here, like, that says if, conditioned on, or if defined. So this seems that this is a data point that's always defined. It'll always be in the dictionary and is not likely to throw us in error. So I just kind of went with that one. Maybe some of these other ones would have been better. I don't know. But yeah, it's maximum precipitation intensity.
But you said you checked it against the actual table and it was accurate, so it probably just worked fine.
Yeah. Every time, yeah.
And there were values for all of them, so yeah.
Yeah, that's the other thing.
Another way around it too is you could just put, if there's no rain, just fill it in with no value, and you know what I mean, with a non, and then calculate off that. But that's another way, right?
Yeah, or it was like a precipitation intensity max. It says a maximum value of intensity during a given day. And if this is 0, that means that there was no intensity to measure. But even that was sort of an inference I was making. So yeah, that's the thing with APIs. You just kind of have to, like, sort of figure out and just guesstimate, like, what they're trying to do. But yeah, there's any number of these that we could have used. But the most robust one that I found was probability, and it was also the easiest to work with. So I just went with that. I mean, you guys, if you want to mess around and try the other ones, it'd be fun. I kind of wanted to, but also didn't want to, and just wanted to get it over with.
Yeah. No, good. I mean, it's good to, like, look at stuff that that you chewed on for a while, because then we can, you know what I mean? Hindsight is 20/20, and we can go, okay, how much do we want to chew on this, and how much do we just want to get it done? So, cool.
All right. So now the next one, what it is. So we just use precipitation probability. It always return a value. If the prob is greater than 0, then the self.precip attribute that I defined for this weather getter object is rain. Otherwise, it's clear. In the solution, they did true or false. It's really the same thing, but maybe true or false was better, because it saves me down the line a little bit of extra work.
Interesting. And you didn't put any of that self.anything after you initiated it, because you loaded it all up in the parameters.
Yeah. I mean,
typically, except for self-precip. Okay.
Yep. That's the only attribute that I defined for this class. I think they did a bunch of other ones where they stored the variables as attributes, but you don't really need that, because you're never going to refer to any of those attributes later on. The only attribute that you're interested in is whether or not it's raining. And like you could, because you could use those attributes to plug into later attributes to get the final attribute, but you don't need to. So I just kind of use these internal variables that are not accessible outside of this class. Because when are you gonna ever have to access them outside of the class? And then I just like, and I think that that's a good. I want to say that's a good programming practice because like, I don't know. I think that way like they don't get stored in memory or something. It's only like the attributes that you define that get stored, and then these ones they kind of disappear after the function ends. I think I'm not sure, but anyways, that's how I did it. So yes, you have just the self dot precip, and that's basically this is essentially a function. Um, and like it could have just as easily have been just a function, but they wanted us to write an object, so I wrote an object, so whatever.
And you don't have to explicitly write object after weather getter to get it to run. Like in between the parentheses. Interesting. Okay.
I didn't, and it worked fine for me. Is that something that you do? I didn't even know that.
It's just something I've noticed in different classes, and so that's maybe a James question I ask him.
Maybe. Yeah.
Yeah.
I just did it like this, and it worked. Is that where you define the parameters, like self or like whatever? I don't know.
Yeah, and that's me. See, so here's me. I'm so literal, right? And I like to just like see how things are done, like you said, and reverse engineer them.
Right.
And a lot of times when I see these classes being built, they explicitly call object after.
I see that. I see that now in the solution. Right. I see the class weather getter, and then in the brackets it says object. I don't know if that means that we're supposed to be passing an object into it when we instantiate this class, or what that word object is doing. Like, I'm not 100% on that. Do they use object anywhere later down?
Well, I've seen it, like when they were teaching OOP.
Really?
So that's why I was asking. Yeah. But I mean, if it works without, again, like.
But I don't know. I mean,
just something I noticed.
But it might be something important, so we should probably go back and take a look and see what that's doing. It seemed to work okay for me without it, but you never know if it's doing something behind the scenes. So yeah, probably something that we want to
and so where did you pop in weather getter? So like when you
all right.
I know you'll get to it, but
okay, so now that's the next step. So all right, so now what we do, we have a matches 2011 data frame, which pulls the data frame of all 2011 matches. We're going to take a new column. We're going to define a new column for it called precip. And the values of that column are going to be matches 2011, the date column, and to the date column, we're going to map lambda x or weather getter API key x dot precip. Right? So what that's doing is that for each value in date, it's going to initiate a weather getter object. We're going to pass in the API key, and x is the date because it's a lambda function that's mapping it. So x is each date, and then we're going to get the dot precip attribute of this weather getter object. Do you get that?
So slick. Yeah, that's cool.
Yeah, the lambda x is pretty confusing. Yeah, it's confusing to come. I wouldn't be able to come up with that if I didn't see it.
But there's a downside to this. The downside is, like I said, it's going to cycle through each x. It's going to go through each date. So, and it's not doing the dictionary mapping, which saves API calls and you only call. Like I said, I just wanted to quickly do it. So this is really a quick and dirty way of doing it. But yeah, but James also did do map apply, but he did it differently. All he would do is that instead of instantiating the object in the lambda function, he would pass an x to a dictionary that had already been constructed for the unique dates, and then slice that dictionary for that date, get the rain value, and map that to the precipitation column, if that makes sense.
Yeah. And that's how I would do it too, because then you're calling less, right?
Yeah,
you have
absolutely
because there are multiple dates, right? So you're calling, and I think ends up only being like 192 dates versus 992.
It's 150 values. That's no doubt that's the right way to do it, and that's why again I say I was just being lazy, and I kind of thought that there probably was a lot of dates anyways. I didn't realize that there was only 150 unique dates. So I thought, there's probably 700 dates anyway, so might as well just loop through the whole damn thing. But no, it's definitely better to find the unique dates and minimize the amount of API calls you make. So that's the one sort of layer that's missing from my solution. But it brought the dates in and it got it working. So I had to pay 10 cents, but whatever. So team class. All right. So then I made and James in his lesson he had mentioned that he was going to that he was he was thinking about making a team class, and that's what I did because I thought that when it all right. So the Mod 2 object-oriented module that we did is like the first time that object-oriented programming really clicked for me because I had sort of been dancing around it in the past, but I'd only ever really done functional programming. And I kind of knew like, okay, these are objects and you know what they are, and the whole idea that they're supposed to model like a real world thing. But I think the line that really struck out was like when in the module in the introduction they said, think of objects as basically just containers to like group together variables and functions that are related, and that's what really hit me. Like, oh, okay, now I get it. It's just a way to organize your code into like chunks that are modular. I get it. But yeah, so the idea that like and then in practice you want objects to sort of mirror real world entities. That's not always the case though, because like the weather getter object that's not really like a real world thing. There's no thing in the real world that's called a weather getter object. But when we think of it as just a way to sort of organize functions and variables, then it makes total sense. But anyway, so I decided to go for like the classic sort of object, like model a real world object, which in this case was the team. Each team is an object and has attributes and it does things. So we did that. We initialize the team. The name we pass in the name, and we pass in a data frame. And the data frame that we have to pass in is basically just the 2011, the matches 2011. We're going to do that later. So self.name is name, self.tally home, tally home. These are all functions now. In the initialization, what's happening is you set the name attribute, then you have the tally home function that's called, and it's defined below. Then you have the tally away, which is defined below. Then you have the rain tally defined below. Then once you run those functions, those set some attributes, and you use those attributes to calculate attributes in initialization. So you come sort of back to initialization, calculate these attributes, and then those are stored in the object. Okay, so to generally break the problem down, right? So the idea is that we want to calculate all the goals and all the wins for each team, right? Now the first thing that you realize is that for each team, it's either going to be a home team or an away team. So the way that I approached the problem was that first we want to figure out all the times it was the home team, get those goals and get those wins, and then we want to see all the times that it was the away team and get those homes and those goals, and then we want to add them up, and that's going to get us our total goals and our total wins. And that's and I think that's kind of how James did it, and it's kind of how the solution did it. But yeah, so it sort of helped me to break the problem down into those two phases, right? So the first function that we define in the object is tally home, and this is just tallying all the stats for when the team in question was a home team, right? So the way I did it was James here used the group by function, and I wasn't exactly sure what he was doing. I kind of had an idea, and I'd never seen group by used like that. But it was interesting because I thought it was kind of like a more quick solution. But I just did like a classic slice, right? So this object gets passed in a data frame which consists of like the whole 2011 matches, right? Then the tally home function takes that data frame, it slices that data frame such that it returns a data frame where all the home team values are equal to the name of the team that we pass in when we initialize the object, right? So now this is basically what's going to filter this data frame for just this team when it was playing the home team.
So do you have to know the names of the team and explicitly pass it in on this function then? Like you have to know ahead of time, or it's just going to go loop through one by one?
No, you have to know. You're going to pass into this. This object will take one team name. That's all it's going to take, right? You can only pass the name of one team. Later on, this is going to be used in a loop, and that loop will pass in one by one the name of each unique team into this object, and it's going to instantiate the object for each team run the statistics, calculate the statistics, and then populate them as variables of the object.
Got it. Okay.
So self.home matches, we're just going to do the length of home matches data frame, which is the first data frame that we pulled, because basically it's the number of matches that team played as the home team. Self.home goals is equal to home matches df, where the FTHG column, we're going to sum the FTHG column, right? Which is basically, so this is the column that tracks the goals.
Yeah,
of the home
all
team.
the goals.
Yep. We're going to do that sum. We're going to do sum of the FTR, which is the victory, where it is equal to 8. So this is adding up all the times the home team won, and that's the home wins for this team. Then it's going to do rainy days, which is just the sum of home matches data frame where the precipitation was rain. So this is basically all the days where the team played as the home team and it was raining. Then the rainy wins is all the days it was playing as the home team, it was raining, and it won. Okay? So now it's going to, and then up in the initialization, it'll go back and then it'll calculate the rainy win percentage by referring to these, right? So now we're going to do tally away teams, which is basically doing the same thing that we did for tally home, except this time we're going to slice the data frame for every time it was the away team, and the rest of it is the same thing. We're going to length, number of goals is away, the wins where the value was A, and again, we're just going to sum it for when percent was rain, and where it won, and the away matches was rain. Now, then this other function is just going to tally the rainy days, and it's going to basically just add all the days it played as home team and it was raining, and all the days it was away and it was raining, and then the wins is basically just home wins when it was raining and away wins when it was raining. And now this pulls the histogram, okay? Now, the histogram part is interesting. I tried to save, just pull, the fig, right, or the plt.hist and save that histogram object, the pandas object, into Mongo, and Mongo freaked out, and it says you can't save that kind of object in the data frame. And that's true because Mongo has, a very, limited set of data types that you can store in it, right? There's, text, integer, float, and then the best you can do is something called blob, which is just a stream of binary data, right? And that can be an image or whatever. So then I tried to convert the image into a binary stream, which was problematic, and I wasn't exactly sure how to go about it. Well, I mean, I could have done it, but then as I was doing research, then I found out that it's really, people generally seem to be of the opinion that it's not a good idea to be storing pictures in a Mongo database anyways, because there's no point to it. You're never really going to be able to search by image, right? Who's going to write a query? So there's no point. So the convention appears to be that you save the images on a disk, right, on your server or whatever. There's a file path, and then you store the address to the image in the database. So that's how I did it, right? I saved all of the images. If you go back this is the home folder where it's running. There's a folder here called histograms, and this has all the images for each team's histogram. And then in the function, all it does is it makes a figure axis, it plots a bar, and I did a bar chart, not a histogram, because how would you do a histogram? Because there's no data frame already that you can't really do hist in this situation. So I did a bar chart where X was wins and losses, and the height was just all the wins, and then that's the Y value, right? So yeah, because the existing data frame there's no way to do a histogram, I thought. So that's just how I did it.
I know, I'm trying to, that's
guys.
Hey.
What? This is nonsense. They make you pay for more than 40 minutes?
I've hosted a few and they usually extend it, but I think because you logged out and there wasn't a host anymore, you must have logged in as a non-host, that they ended it early.
That's weird. Alright, I need to take time to figure out how Zoom works better. Alright, so where were we?
The histogram.
Okay, hang on. Oh, let me share my screen. Okay, you guys seeing my screen? Okay. Alright. So that's because okay, you know, the data frame, like I said, they've split it up into home team and away team. So you can't really, there's no easy way to do a histogram because it's not like you're just counting the number of occurrences of a value in just one column. You have it split into two different columns. So you'd have to do like a really complex, weird join or group by or something. And I just thought it was easier. I already have the stats that I need, and the histogram is just to show how many times did they win versus how many times did they lose. That's the point, right? It's counting wins versus losses. So we already have the number of losses, the wins. Just subtract that from one to get the losses, or the total number of matches to get the losses. And here we count ties as losses, right? I didn't because I don't want to go back and do all of that. But basically, that's what I did. I just and that so I plot that on a bar chart. X is wins losses. Height is determined by self dot wins, self dot losses. Losses are calculated up here in the initialization. It's self dot all matches minus self dot all wins. And then the last thing in initialization is self dot histogram. So this makes the histogram. Then self dot hist is equal to okay. So the self.hist is now just a string that's a file path to the image that we save of the histogram, and it's histograms is the folder that's in my root directory for this folder for this notebook. So it's histogram / plus self.name, which we got up here as a string, plus .png. Then we just do a fig.savefig self.hist. So savefig will just save the histogram as an image, and it will take self.hist as the path to save that image to. And then the self.hist attribute of this object will just contain the string that refers to the path where the image is stored.
Slick. I like it. That would have taken me forever to try and come up with. So thank you for letting me spend time with my family.
I know. Because like I said, it's, there are ways to store, and the solution, just saves the hist object right into Mongo, and, I called BS on that because I tried that. That does not work. So I don't know what they're going for there. But
I remember seeing something in Mongo, as long as it was a PNG file, you could, or something like that. And I see you're saving it as a PNG.
But that's a whole rabbit hole unto itself, right? I don't know if databases have a limited set of data types that you can store in each thing. I'm not exactly sure how NoSQL works. When I was doing research, all I know is I was trying to find out how to save an image, and there was a complex thing about converting it to a bit stream, and you could just store a blob of binary data. And just trying to convert it to binary seemed annoying. And then I read in another place where it was people were saying, why would you bother storing an image in the Mongo database anyways, right? There's no point. It's not like you can ever do a query on the image, right? It's nobody's going to type, the binary value for the image and then try to pull that. So the best thing to do is to just save it. And I've seen this done in other contexts. I work in eDiscovery. We have these huge databases of documents that we get from our clients. And the database itself, it's very common to just store the file path to the image of a document instead of trying to store the actual image in the database, which you can do, but we use SQL Server, which I think allows for that somehow, or they also have some way of converting it to binary. But it's very common to just store the location. It's also supposed to be faster than trying to retrieve the binary blob and convert it back. It's supposed to be faster to just have it saved on a disk, have just a database entry that has the file path for that image, and then just pull the file path when you need it, and then just plop that in wherever, in your HTML tag or whatever, and it just finds the source. And then hang on, I got Amazon. Thank you. All right. So so that's how that was my approach to that problem, and it worked fine for me, I thought.
I can get behind the rationale behind it too. That makes sense.
Yeah. All right. So now the next challenge is that now we want to pull the list of unique teams that played in 2011, and that's more complex than it sounds because first of all, we only want the teams that played in 2011. But then, of course, we run into the problem of the fact that we had the two columns, home and away. So here's what I did. I wrote this. I just wrote one SQL join to pull a table and then just get the unique values that way. I got all my unique values in SQL, and then I just turned it into a data frame and a list. So this query pulls in all the unique teams that played, I think. Yes.
That's funny because I did it opposite. I pulled it all in and then played with it in Pandas to clean it up that way.
Yeah, that was the other way to do it, but for some reason, I don't know why, I thought it was just easier to write the query. So what I did was, we want to pull the count. Okay, here's what this is where, you know how the database has 4 tables, right? It has the matches.
Yes, I started getting funky in there.
I was wondering at first why the hell we needed those, but then when it came time, wait, I can use those for that. So here's what I did, okay? I pull the count of match IDs, which it doesn't matter, and the team name and the unique team ID from teams and matches. And teams and matches is the data frame that maps, there's a match ID and the team that played in it, and then another match ID and then the home away. That's the one that kind of flattens the home and away into one, right? So you have one column with just a list of team names, and next to it is the match IDs, that they were in. It's supposed to be like an intermediary table for a many-to-many relationship between matches and teams. So what I do is I pull unique team ID from team and matches. Then I join that with unique teams using unique team ID because, it's the teams and matches doesn't refer to team names. It refers to them by their team ID, which again was an unnecessary layer, I thought, but I don't know. Maybe there's teams that have the same name. So this is just to sort of translate the team ID into a team name. And then we do where match ID is in, select match ID from matches. This is basically the query. The subquery is the one that we did before to pull the matches from 2011, right?
Yeah, so I just did the big one.
Yeah. So
I was lazy.
Yeah. So this is just going to find, so it's just going to find all the match IDs that are in the 20, so it's going to find all the match IDs that are in the 2011 match table, and then it's going to group by team name, right? So what this will do is it'll pull match IDs, but the match ID will occur more than once, and the teams will occur more than once because each team can be in multiple matches. But you'll have one column of all the teams that played in any match in 2011, right? And then you can, if you just group by the team name, that'll give you just a unique list of teams. Now we convert that into a Pandas SQL down here, and then we just convert the team name column to list using that, and that gives us our list of unique teams. So that's how I went about doing it. All right. This is a test. I just wanted to test. I just pulled a test team object. I should probably just delete that. I already need that. All right. Delete that too. And also delete that. Okay. So now we have a list of all the unique teams that played in 2011. So the last step is to add this all to Mongo. Set up the client, set up the collection, set up the database and the collection. Now we have our Mongo handler class, right? We are going to, this is really simple. So all it's going to do is, the class will take in on initialization. Why did I do that? I don't know how the hell classes are working. I need to look at that again. But
yeah, I know. I keep looking at that over and over, and I'm like, how?
How's that working? Yeah, that's a good question. I mean, it worked fine because you'll see, like, look, down here, I have all of it. But, so what this doing in theory is, it'll initialize self-collection. All right, so on initialization, you're going to pass into this the collection, which is the database collection, which is up here, team stats, and then the name of a team, and also a data frame for that, for the season, right? So this is going to be like the 2011 season data frame. So we're going to pass name and team name and data frame. Then the first thing we do is we're going to create a new variable called team, which is going to instantiate the team class that we set up before. It's going to create a new team object into which we're going to pass the name of the team and the data frame. Then the object will do its magic, run all the figures in the background. Then we're going to create a record dictionary, and in the record dictionary, we're just going to set the key value pairs. The name is going to be, and the value is going to be the different attributes of the team object that we made up here. So the name is going to be team.name. Goals are going to be team.all.goals. By the way, heads up, you definitely want to sort of explicitly convert these data types, because I didn't at first, and when I was doing calculations in the object, it was returning some kind of NumPy float object, which is still a float object, but I guess Mongo doesn't recognize it as a valid object that you can give it. So all you have to do is just sort of explicitly convert that to string and integer, and then you'll be fine. So team.all-goals, team.all-wins. Histogram is going to be the string value of team.hist. Again, remember, this is a string that refers to the file path. And then rainy-wins is going to be float of the team.rainy-win percentage. These are all just attributes of the object that are calculated when we instantiate a team object. The record will pull all those in. And then we're going to just do collection.insert one record, and voila, it's in our data frame.
So I have a question right here. How does it, scroll back up, how does it pull the team and the team name? That's coming from where? Where does that get? I'm still lost on how that would pull for each team.
All right. The name has to be passed into this Mongo handler. And we're going to do that down here, where we are going to, remember how we already have the list of teams up here that we pull? So team list is a list that has each element of this
slices. Okay.
Right. Each element of this, this is slicing the data frame that we pulled from the query to just get the team name column and then convert that to a list. So now team list.
So it's the unique names. Got it. Okay.
Yep,
I'm tracking.
Yeah,
it's a variable. That's all.
Yeah, it's a list, and each element of the list is a string, which is the team name for each team.
Bless you.
So, and now down here, we're going to say for team and team list, i.e. for each string in that list, the database entry is equal to Mongo handler. Team stats is the collection that passed in. Team is the loop item, right? That's the name that's going to get passed in. Matches 2011 is the data frame that we previously pulled for all the matches in 2011. So the only value that really changes in this loop for each iteration is the team variable. So it's going to just do this for each team that it pulled in the unique list, right? So each time it goes through, it'll get one team name called the Mongo handler object. The Mongo handler object will take the team name that we passed in and instantiate an object and pass the name into that, and then also the data frame, and then that will then slice the data frame for that name, do all the calculations, and then spit back out a record. And then this loop down here will go to the next name, pass the next name to Mongo handler, which will pass it to the team class, do the calculations, and so on and so on.
Slick. That is so cool. You got to feel good like you did it all on your own. Like, I don't know. That would have taken me a lot longer had I stumbled by myself. So I appreciate you sharing.
It was fun. And so like down here, and then and then what I did was, so I did it on my own, but like then you're always wondering if it's right or not. And it's to check kind of what I did was just for y in team.stats.find. And when you do team.stats.find, that's basically a blank query that pulls in all of the records in the collection, and then you print each record in that collection. So when I did that, and I printed basically what were all the records in the collection, and you see down here, each one of these is a record. And you'll see team name, Aachen, and then golds is 30, wins is 6, and the histogram location is there, and then the rainy win percentage is there. And that looked right.
Got it.
Right? I mean, it looks...
Yeah, and that's what's being loaded up into Mongo so there's the object ID.
Yep.
And there's the dictionary that Mongo can handle. Okay.
Yep. That's already in. No, that's already in the database. This is pulling it back from the database. Mongo Handler popped it up there. This query is pulling it back down, right? So we're basically now pretending like we're retrieving data
that's
from...
the find. Yeah.
Yeah. Yep, team stats.
So cool.
Yeah.
Okay, one more question.
Mm-hmm.
What are you doing with Matplotlib Ag? What is that on line input 25?
That is to stop it from spitting out a histogram each time it goes through the loop. And apparently
I see.
That's the way. And it was annoying. I had to bounce around Google to figure that out. But that's apparently how it's one way. And even then, I'm not exactly sure how it works, but it works sometimes. But yeah, the idea is that otherwise, it would just every time the object would instantiate, and it would go to the histogram method, and you would do AX is equal to PLT.bar. It would just plop it, and I don't know why.
Every single time.
Yeah.
Okay.
There's probably a better way to make it not do that, but I just wanted to shut it off, and the best way I could find was to do this. And I should probably... Then I got this error message down here that more than 20 figures have been opened. So even though you don't see them, they're still being opened in memory. So I should probably have done... I'm pretty sure that this function, the histogram function, could have been written a little better. Maybe to close the figure after saving it. I think that's one thing I could have done. But this definitely, I think, is something that, again, I was winging it. So I think this could have been better.
What's an example of a histogram? Can you pull one of them up just so I can see what it looks like?
Sure. Hang on. Okay, so let's see. We're gonna go to the first one. There we go. That's wins and losses.
And it doesn't include rainy days, or is this during rainy days?
They didn't ask for that, so I didn't do it.
Oh, okay.
Yeah, they just said the histogram of whatever it was, wins and losses, right? A histogram of wins and losses. So I feel even better about not factoring in ties, because I was like, oh, I should probably factor in ties. But they just say wins and losses, so I give them wins and losses. So yeah, and then so down here, and that looks like it looks like a valid enough data set, right? It looks like the calculations are possible, right? 40 goals a season, 10 wins, and it seemed kind of feasible. There's one for each of the
rainy wins. It's they're not all 100% rainy wins.
Yeah,
that was something that would be interesting to see, because on James's, when he used icons, remember he didn't want to pull everything, so he only pulled 20, and they were all rain.
Yeah.
It's okay, I got your calc. It's 100%. We don't even need to do it.
Yeah, and I did that. Well, that's why when I was doing it, this is a more cleaned up version. As I was doing this, there was messier, and there was testing that I did along the way, and all kinds of weird stuff. But yeah, I was doing that. I think after the weather getter, I sliced it to see. Well, yeah, kind of. Well, display matches 2011. Before I was doing a smaller subset, I would only do 100 matches at a time. And yeah, I think I also had that issue at some point where they were all rainy or they were all clear or something, and that was problematic. But I think part of it has to do with just really getting the right data from the API itself, and figuring out how they're delivering that content and what to do with it. So
yeah, and then how to put them together. I think that was the biggest challenge for me, is how to get them joined in the same table, and then the histogram thing was in my brain for days, and I was avoiding it, I admit.
Yeah, it was very irritating. It was not fun.
Yeah. Well, thanks for taking one for the team.
No worries.
I'm glad you did it. I'm glad you're ahead of the team.
You guys are just lucky that
you pulled a lot of stingers.
Yeah, you guys are just lucky that I'm mildly narcissistic and I love to show off stuff.
I will love your narcissism then. Keep it up.
All right. All right.
Well, cool. I'm gonna make sure. I'm gonna go snoop on that. I'll be creeping on your repo.
Yeah. Yeah. You find me on GitHub, or I'll send you the link for this one.
I did.
Yeah. Or I'll send
No,
you
and I knew that one. I got that. I was grooving on that. That helped me figure out a lot of stuff. But
Yeah.
I want, the actual repo, and then I can go creepo on your repo.
Okay.
Right on. So it's the index, right?
Wait, no, this isn't it. Say that again?
Yeah, like up there. So it's the index that you. Oh no. On yours.
Oh, on my tab.
There's a con 314. Let me go see if I can find you really quick.
Yeah, the con 314. Let's see.
And then I'll just search repo.
Yeah, this is it. For
and
some
then
reason it's not showing down here, but if you go to index,
it says 3 days ago. Mod to some.
Let me just make sure. Okay, yeah, so it's all in there. Yeah, you got it. Did you get the repo, or do you want the link still? I'll send it to you anyway.
I see. Hold on. Yeah, I can see. 57 files. Let me see. Bin, histograms. Oh, this is all the histograms. So I got to go on the actual index.
All right. The link to
Oh, we rolling now. I got you. I see it. Sweet.
Yeah. All right. So
thanks for sharing.
No worries, guys. All right. Did we record this?
Yeah.
All right. Do you wanna upload them or?
I don't know. I tried uploading to YouTube and I couldn't do it, and I tried Dropbox and I didn't have enough space.
Can you on I don't know how what is it you said QuickTime, but like can you? I think if you just split it up into like volume 1, 2 like that, then it should let you do it.
I can try.
How about Con? Don't you have a huge server